Well, howdy there, Internet students. This is Mr. Hermanson here. We're going to do the second part of Part 4, Lesson 7.2. Today we're going to deal with situations where we have variables on both sides and also learn how to write inequalities for problems and then solve them. So let's start right here on the second page of this lesson. You want to fence in a rose bed that is adjacent to a deck. The length of the deck is 14. You have at most 44 feet of fence. What are possible widths of the rose bed? So I think what they're saying is you have this deck 14 feet long and you're going to plant flowers along this deck. Now we know the one dimension is going to be 14 for our fence. Let me draw that in a different color so it looks a little, so you know what I'm talking about. We actually will only need 3 sides of fencing there. Let's call these 2 sides X because we're not sure what they are, but we know this side's 14. So using the perimeter formula, which tells you that to find the perimeter, you do, well, basically you just add up the sides. So, so we need to add 2 X's and a 14 to get our expression. So 2x plus 14 will represent the perimeter. Now, since we have at most 44 feet of fence, that means that I'm going to use less than or equal sign to represent that. Okay, now I'm ready to solve. I'm going to use my balancing method here. And I'm going to take away this 14 from both sides. That gives me 2x is less than or equal to 30. I didn't have to switch the sign around because I didn't multiply or divide by negative. And divide both sides by 2, and I get x is less than or equal to 15, which tells me the longest amount I can use for a width is 15. Okay? All right. So I think you should pause right now and give this a shot. This next one, read it on your own. See if you can write the inequality that would represent that, and then maybe just start the video back up and you can see if your answers are right. All right, your answer should look like that. Now I'm going to skip over problem 3 because we did that on yesterday's video, and we're going to go to problem 4, and this is solving an inequality with variables on both sides. So so we have to do what we used to do when we were solving equations is we would take away the smaller amount first to get rid of the n from one of the sides. And so so what I'm going to do here is subtract 4n away from this side, get rid of that. Whatever you do to one side, you have to do to the other. Now, always keep in mind that if you multiply or divide by a negative, you have to switch the signs. I didn't do that, so I'm going to still have less than here. And I get 3n minus 13 on the right side. I'm going to add 13 to both sides. And I get 15 on the left side is less than 3n, dividing by 3. And I get 5 is less than n, or n is greater than 5. All right, now just a reminder on how to check those answers. First thing you want to do is check the end point, which is 5. So I'm going to let n equal 5. And when you let n equals 5, then the two sides of the inequality should equal each other. So this should be true. And 4 times 5 plus 2 is 22. 7 times 5, 35 minus 13 is 22. So that one checks. Okay. And then we're going to check one other point of the solution. So I have to pick some number that's greater than 5. And I want to pick an easy number to use, so I'm going to use 10. That's greater than 5, so it should be the number on the left side should be less than the number on the right. So 4 times 10 plus 2 should be less than 7 times 10 minus 13. And 4 times 10 is 40, plus 2 is 42. Hopefully that's less than 70 minus 13 is 57. So that is definitely true. Checks. All right, why don't you try this one? Draw your straight line there and do your balancing act to get the answer. And then you should pause right now and then check back. And all right, that's what that should look like if you were doing it correctly. Okay. Problem 5, inequalities with special solutions. Let's just see what happens here. I'm kind of curious why they're saying that it's special solutions. Who knows, huh? But we'll find out. So draw your line. And so let's see, what do I want to do here? I better get rid of those parentheses. So I'm going to do 14 minus 6n is less than or equal to 14 minus 6n. Whoa, that's exactly the same thing on both sides. You can go ahead and like add 6n to both sides. That'll give you 14 is less than or equal to 14, which is always going to be true, right? When you get that kind of a situation, n could actually be any number. So we call that an identity. I'm not going to hold you to remembering that word, but it means that all real numbers work, or anything works. Anything goes. All right. Go ahead and try work out B here. Actually, why don't we just do it together? So I'm going to draw my line there. On the right side, we need to simplify. Do the 9p minus the 5p. That makes 4p plus 6 is greater than 4p plus 3. I'm kind of seeing something going on here. It just doesn't seem right because you really have, on this side over here, you have 4p plus 3. Over here, you have the same thing, only instead of plus 3, you have plus 6. Seems like you would always have more on this side, like 3 more. So how could the left side ever be greater than the right side? But let's work it out and just see what's going on here. Subtract 4p from both sides, and we get 3 is greater than 6. That is not true. And what that tells us is there is no solution. Okay, so here's what you're going to do now. You're going to do the next problem. I think it's going to be one of the two that we just did. See if you can figure out what it is by pausing and then checking back. You should have seen that that was false and that there's no solution. All right, these enrichments you can do if you want. And other than that, I think you're ready to do your assignment. We'll talk to you later. Mañana.